Okay, let's get started with week 1. And before we go through chapter 1, let me first talk to you about the labs. You don't have to come to the campus to do the labs. We will not be meeting unless there's a group of students who really need help, and we are going to schedule a time that's convenient for everybody and for me to come over and answer some questions. But generally, all the labs are done on your home computer, um, and you will be submitting the completed labs into Canvas. A little bit, I'm going to give you information about the labs. You will have to, and I'll post this as well. Um, there's several software you need to install on your home computer, on your laptop or desktop. We'll be installing a hypervisor, and then you'll be installing Fedora VMware, and then you'll be installing Windows 10 VMware as well. So if you click on this Word document, if you click on any one of them, hold the Control key and then click, and it's going to take you to this home requirement for installing, and then go through and each one of them click on the instructions, and then it'll walk you through and just pick the default values. And then installing Fedora, hold the Control key and click on installing a Fedora VMware, and that should take you to this page on how you can download and install the Fedora workstation. And then lastly, on how you go about installing Windows 10 virtual machine. These are necessary for you to run the labs at home. If for some reason you're not able to install it at home and you're having difficulties, then please let me know. Then I'll have to make some arrangements under certain circumstances that if you really can't do it, then I hate for you not to do your labs and miss out, and hate for you just to go to college to do that. So we'll work something out where we'll try to install this on a server, and using Splashtop we'll try to access it. We haven't set that up. I need to know first the number of students who are not able to install it, and then we will work through the college IT folks to get that taken care of. I'll post this document in Canvas under week 1 as well. Okay. All right. So getting back. Let's go to modules, and then by Sunday we have September 2nd, we have lab 1 and homework 1 due. So if you click on lab 1 document, and it kind of walks you through each step of the way. So go through it, and then once you finish this, submit this document in Canvas. All right, now let's go through and get started. What I need for you to do is read chapter 1, and then after you've read chapter 1, then go through the slides. You can download the slides and then review them. So the objectives are explaining the basic operating system concepts, understand the history of operating system development, how operating systems work, and talk about the different types of operating system, and then discuss single tasking versus multitasking. We should also be able to differentiate between a single user and a multi-user operating system, and then talk a bit briefly about what are the current operating systems out there. So computer functions and features can be broken down into three tasks that every computer performs. You have what you do is input, and then you have something called processing, and then the output. Functions above involve some type of computer hardware, but the computer hardware is controlled and coordinated by the operating system. An operating system is a specialized computer program that has the following features. It has a user interface, a file system, and then processes and services. What is a user interface? That provides a mechanism, a method for users to interact with the computer. And the operating system stores is a method by which the operating system stores and organizes the files and manages access to these files. A process is a program that's loaded into memory and then it's run by the CPU, that's the central processing unit. A service is a type of process that runs in the background behind. And then what is the kernel? Kernel is the heart of the operating system. That's another way to call that. And what are the different types? What's a desktop versus a server operating system? The desktop or the client OS installed on a personal, there's a PC that is used by a person at a time and may be connected through a network. And you have desktops like in the work, you'll have, let's say you have 50 employees, every one of them have a desktop and they're all connected to a server. And a server operating system installed on one or more powerful computer that is connected to a network, most probably a local area network, and enables multiple users to access information, and mainly for email, file system, and software. The traditional server often used by a small or medium business. You have the rack-mounted server, that you have CPU boxes mounted on racks that hold multiple servers. And all servers often share one monitor and a pointing device. And then you have the blade servers, looks like a card that fits into a blade fitting. A blade enclosure is a large box with slots of blade servers. You have companies that are medium-sized to large organizations that use blade servers. What is an input and what's an output? The task or the basic or the pretty basic function of an operating system is to take care of input and output functions, that is the I/O functions, which let other programs communicate with the computer hardware. The examples of the input-output tasks are, you take the input from the keyboard, mouse, or other touchscreen input devices. You handle output to the monitor, or you can output to a disk, or you can output to a printer. Manage network connections such as the local area network or the internet. You have the internet and then the intranet. Control input and output for devices such as the NIC card or the network interface card. Some examples of input-output tasks are control information storage and retrieve using various types of disks. You can also enable multimedia use of voice and video composition or reproduction, such as recording video from a camera or playing music. Here's some examples, and figure 1-1 shows the general tasks of the operating system. And a brief history about the operating system. You had initially computers were used on a large automated, like a calculator for mathematical and statistical problems. You had legitimate use can be traced back to hundreds of years or more, but there are no practical designs used by significant numbers of people until the late 1950s. Operating systems were often not able to do more than read punch cards or tape and write output to machines that look like a typewriter. It did not take long before you started seeing applications that came out to do something useful for the broader audience or people, more people, right, in general. Computers of the late 60s and 70s were pretty much, if you look at in today's standards, were crude. But they are also, at that time, for that time, they were quite capable. Contributed to the development of space travel. You have submarine based ballistic missiles, and then you know the entire global community, financial community, is interconnected. And this is also because of the beginning of the internet, the creation of an input-output device to display terminals and magnetic disks. You also have creation of operating system as OS 8 and Unix. In the mid 1960s, a simple programming language that was developed by Dartmouth College, and it was called BASIC. It was the beginner's all-purpose symbolic instruction code. And then in 1975, Bill Gates wrote a compiler software that turns computer code into people code that is understood by computers for BASIC. Sold it to a company called Micro Instrumentation Telemetric Systems, MITS, which became the first company to produce a desktop computer. Bill Gates started a new company called Microsoft, which led to the development of Microsoft Disk Operating System, or MS-DOS. Remember that? Many of you probably were not even aware of that, right? MS-DOS was the first widely distributed operating system for microcomputers that had to be loaded from disk or tape. Then you had International Business Machines, IBM, adopted MS-DOS for its personal computers. Then in 1984, Apple Macintosh came up with a GUI and a mouse pointing device, which allowed users to interact with the operating system on a graphical screen. And in 1985, Microsoft released Windows, which provided a GUI and many of the same functions as the Mac or Macintosh operating system. Understanding how operating systems work. You have the operating system to work. You need the kernel, the resource managers, device drivers, application software, and BIOS. So what is a kernel and what does the kernel do? The kernel consists of an essential program code of the operating system. The key task of an operating system kernel, it schedules computer processes, it manages, it's like a manager, manages resources such as memory and processing time. Jobs that are performed by the kernel may be managing interactions with a CPU, starting and scheduling programs that handle the input-output activities, and such as device and networking activities. They could also handle basic computer security, managing the use of computer's memory, the random access memory, managing priority levels assigned to programs and computer processes. In Windows, the name of the kernel file is called what? NTOSKRNL.exe, and the Mac OS, the kernel is called XNU. What's a resource manager? They help ensure memory is used properly and there are no memory conflicts. Manage how programs are accessing the capabilities of the central processing unit. If there is one PC and 10 programs that want to access the central processing unit, the operating system will give each program a time or a time slot or slice on the CPU. Each program does a little working during its time slice and then hands the CPU access over the next program. The kernel gives the next program or process CPU access for its time slice. Device drivers and the operating system. A device driver translates computer code to display a message or text on the screen, or translates movements of a mouse into action. You need a separate device drivers usually for each of the input-output device. These device drivers contains the actual code or the instructions that communicate with the chip on the device. Here's a pictorial representation of the device drivers that provide communication between the operating system and the hardware devices. What's the role of an application software? Any program a user might use to run on a computer. You could have, word processor, Microsoft Word, spreadsheet like Excel, database like Access, Oracle, or SQL Server, and then even computer games. An operating system manages the communication among the applications, the user, and the computer. Allows application programmers to concentrate on applications that run on any hardware as long as the operating system is able to control them. Here's the role of an application software. The applications programs communicate with hardware through the operating system. What's the role of the BIOS? BIOS, which is called the basic input output system. That's a low-level program code that resides on the chip or the computer's motherboard. It communicates with hardware devices. It also performs or does the post. That's the power on self-test. That's during startup. Conducts basic hardware and software communications inside the computer. Starts a full-fledged operating system that interfaces with the user. Every PC has a BIOS, which is stored in the flash memory chip that does not lose its contents when the computer is turned off. That's the flash memory. BIOS is stored in a CMOS memory chip. That's the complementary metal oxide semiconductor. When the PC is turned on, it runs a startup program inside the BIOS. The program first initializes the screen, the keyboard, tests the hardware, makes sure everything is working well, initiates the hardware disk and other drives, loads the memory main operating system onto the hard disk, right? And here's the summary of the operating system elements. You see it pictorially. What are the types of operating system? Operating systems could be organized by the size, type, and purpose of the computer on which they run. You could have a PC class computers that are designed for individual single users to perform tasks. You could use like Microsoft Word, Excel management, and then networking with other computers. Early operating systems were written for large, big size machines and were quite complex. Applications were written with efficient code and appearance was very, very basic. Today you have no more big machines. We have small and powerful computers that are capable to do more. Today's operating system has to support multitasking, high-speed network connections, and should also have the capabilities of more I/O input-output, powerful input-output capabilities. And there is ways to differentiate between a high-end and a low-end computer. Mainly speed of the disk controller, speed and size of the hard disk, amount and speed of memory, the size of data path, and the speed and the number of CPUs. Computers and operating systems can be looked at in terms of, whether they are able to do time sharing, real time, and multi-user. What is time sharing? A time sharing system is a central computer system that is used by multiple users and applications simultaneously. Mainframe computers are example used to perform massive calculations or to manipulate huge amounts of data. You have sequential processing used by smaller computers where each process is completed, request is completed, and then the data returned before the next process is started. And what is time sharing? Time sharing system is the central system, that computer system that is used by multiple users and applications at the same time. Mainframe computers are an example. They used to perform huge, massive calculations or to manipulate huge amounts of data, such as batch processing. You could have, for example, clearing 2 million checks and updating the associated bank accounts in batches. Sequential processing is used by small computers where each process request is completed and the data returned before you could start the next process. Here's a pictorial representation of time sharing. Real-time systems. A real-time operating system or ROTS receives and processes inputs and produces that required output in a certain amount of time. You could have an industrial plant to control machinery. More important for the response time for an RTOS to be consistent than fast. These operating systems are typically used in embedded system. A computer has a dedicated function with a larger system. Multi-user systems. Multi-user system supports multiple users who access the hardware and software of the computer and the operating system. You have the client-server systems, and then you have where only some of the work is done on a central server, and the rest of it is done on the client. This client-server arrangement was not possible till the PCs came into existence. Well, nowadays everything is done through the cloud. Cloud computing provides, a scalable web-based application and services over the internet that are used by clients through a browser. There are three types of cloud models. You have the private cloud, and then where the computing resources are kept within that organization. Then you have a hosted private cloud that resources are made available through a third-party outsourcer. And then you have the public cloud. A variety of resources are available to any organization through the third party. Here's a pictorial representation of cloud computing. Single task versus multitasking. The earlier operating system allowed programs to directly access the hardware, and that caused hang-ups or system instability or even crashes. Today's operating systems manage access to hardware. Main reason for this is to facilitate multitasking, running two or more programs at the same time. The two types of multitasking is cooperative multitasking and preemptive multitasking. The cooperative multitasking is where when the operating system hands over control to a program and then waits for the program to hand the control back to the operating system. If the program does not give control back to the operating system, then it could hog up the CPU until the operations are complete. No other program that's waiting can run until control is given back to the operating system. That was pretty common in the earlier versions of Windows. Here's a representation of cooperative multitasking basics. Preemptive multitasking is where the operating system is in control of the computer at all times, lets the program execute a little of the code at a time, then forces the program to give up control of the CPU. The operating system is controlled much of the computer resources that is allocated to each program. Computers must use more of its CPU and memory to support the operating system. And you can even predict the behavior of the computer. Here's the preemptive multitasking basics. Single tasking operating system, they execute one program at a time, and to do something else that program needs to be stopped, like MS-DOS was single tasking. Task switching between operating system, when more than one program needs to be run at a time, but only one program can have control at a time. The earlier versions of the Macintosh operating system are task switching. Comparing single user versus multi-user operating system. Single user operating system handles one user at a time. Some of the older desktop operating system were single user, and some single user operating system do not use multitasking, and some do. Single user systems that can use multitasking may use either both cooperative and preemptive multitasking. Multi-user operating system handles multiple users at the same time. All server operating systems are multi-user, and some desktop also are. Always employs multitasking, and for this the multitask operating system uses preemptive multitasking. Some current operating systems that we're going to cover in this text are Windows 7, 8, 8.1 and 10, Windows Server 2008, 2012 and 2016, Unix and Linux distribution, then Apple Mac OS version 10.11. And we're going to talk more in detail in the next chapter on these operating systems. So in summary, all computers perform three basic tasks: input, processing, and output. An operating system provides the foundation upon which to run the components of a computer and executes applications. A basic task of an operating system is to enable a computer to perform input-output functions. Two common types of operating systems are desktop and server operating systems. The history of the operating systems in computers took part a progression from huge computers to large computers to desktop-sized computers that have powerful operating systems. Device drivers can extend the native function of an operating system to provide access and control over different types of devices. BIOS is a low-level program code that operates between the computer hardware and an operating system to initiate communication with hardware devices. An operating system may be geared to run a large mainframe or a small PC of a PC type of computer. Operating systems can be understood in terms of characteristics such as time sharing, real-time operation, and multi-user capabilities. One of the most significant advances in operating systems is refined by the GUI in Windows-based and Mac OS systems. Early operating systems were single tasking, but nowadays the modern ones are largely multitasking. A true multi-user system is one in which multiple users can access and run a single application on a single computer at the same time. So that's a summary that covers Chapter 1. Please read Chapter 1, go through the slides again, and then install from the page that I showed earlier on installing the systems in your home machine to run labs 1 through 12. So there's lab 1, and then you also have homework 1. Homework 1, there are 10 questions, and answer each one of these questions. And then if your answers are overall exceptional for every one of the questions, then you will get an additional 5 points. Please make sure that you do not copy and paste verbatim from the textbook. You need to write this after understanding by reading the chapter and then writing it in your own words. Okay, so if there's any other updates that I need to give you, I will. If not, I will post the next lecture for Chapter 2 on Sunday evening or early Monday morning. Thank you.